Hey y'all. All right, on to type 3, taking square roots. Now I've put my computer here so that you can all see that you should also have your computer open. And I've scrolled down to type 3, taking square roots. All right, now look, I'm gonna do 1. If you click on 2, you'll see that the solution is written over here. So I want you to try reading through that solution after working it out yourself, and then let me know if you have any questions while you're reading through it, if what you get doesn't correspond to what you get here. All right, then I'm gonna do number 2 over here, but again, you should try it yourself before watching the video. All right, and I also want to point out that in number 2, notice that we've got a 2x. It's something other than x, so it's just like that previous type where we had something different from x. And so this is to show you that we're going to be building off of each other, that we're going to see examples within examples. This is like a conglomerate of multiple types. All right, so you should have your computer open while I work through number 1, A1. All right, here we go. Taking square roots. I've got cosine squared, and I need to isolate. The steps are the same. Isolate the trig function first. So first, divide both sides by 4. So I've got cosine squared of x, because over here my 4's will cancel, is equal to 1 over 4. Okay? Now to get rid of this squared, I need to take the square root of both sides. So I'm going to take the square root of both sides. And remember, when you insert the square root, you also need to include the plus or minus. So I'm going to actually put my plus or minus up here so we remember you got to have that plus or minus in front of your square root. Okay? So my square root cancels with my squared, so now I just have cosine of x. And then I've got plus or minus, the square root of 1 is 1, and the square root of 4 is 2. Right? Unit circle. Cosine is 1 over 2 here, cosine to the right, one finger up. So here we're in radians. I've got my restrictions 0 to 2 pi, so we're working in radians. So this one is pi over 3, right? So x is equal to pi over 3. Now I've got plus or minus here. That's the whole unit circle, y'all. Cosine is positive here, cosine is negative here, cosine is negative here, and cosine's positive here. So I'm working in all 4 quadrants. So I'm going to have 4 solutions. Pi over 3 is just 1. Here we've got pi over 3. Pi over 3, then we got 2 pi over 3. There's my other solution. 3 pi over 3 would put me here. So then I go on to 4 pi over 3. And 5 pi over 3 is my last one. I have a hunch that after working through type 1 and type 2 and struggling as much as y'all did, that you just worked through that one and was like, whoa, that's way too easy. Yes, it should be that easy, unless it was really difficult. And then that's okay too, because we're gonna work through a bunch of examples and it's gonna get easy. All right, so here's our 4 solutions. Done. Now again, I want you to pause and try out number 1 for yourself. Now the only difference between A and B is that A has got restrictions between 0 and 2 pi. B, there's no restrictions. So now you're going to have to add that 2 n pi or the n pi depending on your preference. All right. Now I'm going to work through number 2. 2 sine squared of 2x is equal to 1. So again, you should pause the video now and try it for yourself. We want to notice that we have no restrictions here. We can be anything we want. No restrictions on the future of this angle. All right, same rules. First, isolate the trig function. So we need to isolate the trig function. We have this 2 out front. That is not a part of the trig function. Oh, wait, I forgot my 2 in front of my x. Hope y'all caught that. There's my 2 in front of my x, and now it's kind of messed up with my sine squared, okay? So this is like a monster of type 2 and type 3 combined into one beautiful equation. So first, This 2 is not part of the trig function, so I'm going to pass it to the other side dividing. So I've got sine squared of 2x is equal to 1/2. Take the square root of both sides. Go ahead and say it with me. What do I need to include with my square root? Plus or minus. It's okay if you shout it out loud. That's good. You're enthusiastic. Square root of 1 is 1. Square root of 2 is the square root of 2, so I'm just going to leave it as the square root of 2. Now I know you all already know we need to rationalize the denominator. So I've got sine of 2x is equal to plus or minus the square root of 2 over 2. That looks familiar. Sine over to the left. I need 2 fingers up, right? So I've got to be at pi over 4. No restrictions, but I prefer for you to work in radians. So that means that 2x is going to be equal to pi over 4. Okay. Now, just like with tangent from previously, there was the fancy way of doing things that was more concise, and the less fancy way, but still correct and acceptable way of doing things. That is a similar situation here, all right? So first I'm gonna get fancy, and then I'm gonna generalize it. So let's look at our unit circle. Again, we've got this plus or minus, so we're looking at the entire unit circle. We've got solutions in all 4 quadrants, right? We've got pi over 4. 2 pi over 4 would be straight up, right? That's the same thing as pi over 2. 3 pi over 4. 4 pi over 4 would be straight over. That's the same thing as pi. 5 pi over 4. 6 pi over 4 would simplify to 3 pi over 2, so that's straight down. And 7 pi over 4, last one. All right, so we've got these 4 solutions. But remember, we have no restrictions. So we can go around again the unit circle an infinite number of times. We could also go negative pi over 4. That would be a solution because we have no restrictions. So to include all of these, I could add 2n pi, but I could get fancier and notice that these are separated by a distance of pi. So if I do pi over 4 plus n pi, then I'm covering these solutions. So I've got pi over 4 plus n pi gets me here, plus another pi gets me here, plus another pi gets me here. It's a loop back and forth, right? But that means I'm skipping over 3 pi over 4. So I need to also have 2x is equal to 3 pi over 4, also plus n pi, because these are also separated by n pi. So if I go to 3 pi over 4 plus pi, I'm here, plus another pi, I'm here, plus another pi, and so on forever it goes, okay? So again, this is the fancy way of doing things, to be able to look at the unit circle and recognize when you only need to add n pi and when you need to add 2n pi, all right? Now, finish solving for x. Divide by 2, divide by 2, and I'm dividing both of these terms by 2, right? That's the same thing as multiplying by 1/2, right? So this x, the 2's cancel. Pi over 4 times 1/2, pi over 8. And then I'm still going to have n pi over 2. Don't worry about finding a common denominator. The part that has n can always be separated by itself. We don't have to try to include it with anything. All right? There's 1. Over here, same thing. Divide by 2. I'm going to write it separately. That's the same thing as multiplying by 1/2, multiplying by 1/2. 2's cancel, so I'm left with just x. 3 pi over 8 plus n pi over 2. All right, capiche? 2 solutions. Oh my God, and I remember somebody noticing in class that I hadn't been writing that n is an integer, so also include that as part of your solution as well, that we need to define n to be any integer, okay? This is the fancy way. Now suppose you can't remember when you need to add just pi instead of 2 pi. Let's look at that. So another way of writing your answer, that is still correct, I'll still take it. It's just less concise because we're gonna be like lapping ourselves and we're gonna be including the same answer multiple times, but that's okay. We're instead going to add n pi, we're gonna add 2 n pi, and we're gonna count everything that's in 1 revolution. Okay, because I think that y'all can really easily figure out all of the points that are in 1 revolution and then just always add 2 n pi. Okay, so I'm going to have 2x, right? We're going back to 2x. That's our original angle, is equal to pi over 4 plus 2 n pi. 2x is equal to 3 pi over 4 plus 2n pi. 2x is equal to 5 pi over 4 plus 2n pi. And lastly, let's see if I can squeeze it on the bottom. 2x is equal to 7 pi over 4 plus 2n pi. All right, last up, divide everything by 2. We already saw that up here, so I'm going to divide by 2. Same thing as multiplying by 1/2 times 1/2, right? So I'm going to have x is equal to pi over 8. And then the 2's will cancel, so I'm left with just n pi now. Over here, divide by 2. Same thing as multiplying the denominators by 1/2. So x is equal to 3 pi over 8. The 2's cancel, so plus n pi. Divide by 2. X is equal to 5 pi over 8 plus n pi. The 2's cancel once more. And then lastly, divide by 2. X is equal to 7 pi over 8 plus n pi. Cool?